Hello again! In the last video, we finished setting up the HUD and got that all working. In this video, we're going to turn our attention towards setting up and dealing with various states that the game can be in, and we're going to add another element to the HUD to display that on screen. So, let's go ahead and get started. I'm going to flip over to Visual Studio because the first thing we need to do is we need to know what states the game can be in. And we're going to do that with an enumerated value, an enum. And that is going to be an enum. We'll call it the battery play state. It's the same thing that Epic calls it in their version of this tutorial for the single player, so we'll go ahead and just use that for now. And our states are going to be the same. Playing, game over, won, and unknown. Now we just prefix things with as a convention. It's not really a requirement. Also, they made theirs an enum class, but that's not going to work for us. We need this to be replicated, so it's going to be an enum, straight up. And we want this available in Blueprint, so we make this a enum blueprint type. Okay? So now we're good there. And also, in Epic's version, they put this in the game mode, but of course we know that won't work for our purposes. We need it available on clients, and we want to replicate it out to the clients, so we're putting it in the game state. And of course it's a transitory or transient value anyway, so that makes sense because it only holds during gameplay. So let's make this private. We don't need anybody else to mess with this really. Well, the game mode will mess with it outside the class. We'll access it through an accessor. Let's set this up. Now, in order for this to work as a replicated value, because we need it on clients, we have to use this type. It's a enum as byte. We got to track it as a byte. And we use the enum battery play state. And that's our current state. Okay, now as I mentioned, we need this to be replicated. So it's a U property. Also, we may want to have clients do things based on when the state changes. So we're going to go ahead and set up the rep notify for this. So we're going to call it replicated using onRep_current state. I'll just copy that for now. And this is going to track the current playing state. All right, now of course we need to be able to set and get that. We need the accessors. So let's go ahead and we're going to return, and for the getter, we're going to return the battery play state, get current state, and that's going to be const. We don't want to modify anything as a based on calling this. This is a U function, and it's going to be blueprint pure. It's called every time. We'll go ahead and put it in our power category. And this returns the current state of gameplay. We also know that we want to be able to set this value, which doesn't return anything. Set current state. And we're going to pass in a battery play state, the new state. Now this we only want to work on the server, so we will do that. This we're not going to make a U function because we're only going to be using it internally from the game mode, so we'll just leave it without the U function tag for now because we won't need it for here. So this is going to transition the game to a new play state. And this is only usable on the server. So we will make sure that that is true in the code. And finally, we need to implement the rep notify. So that's a void onRep_current state. And that is a U function that doesn't need any arguments. And this is the rep notify fired on clients to allow for client-side updates. To allow for client-side changes based on changes in gameplay state. That's a really long comment. Okay, whatever. We will now just need to flip over to the CPP and actually implement these functions. So let's go ahead and go to our CPP file, and we need to implement the battery play state. Return that from our ANMP game state. This is the get current state, and that's const, which just returns the current state. And then we need the void set current state, passing any battery play state new state. And then I'm just going to grab this, copy that. There we go. Scope. And now, of course, we only want this to work on the server, so we do our authority guard. If role is equal to role authority, then we're going to go ahead and just set the new state. So set current state equals new state. And we may need to do more with this later on, but for now this will suffice. Again, this is our first pass implementation. Now there's a couple other things we need to do for our scaffolding. One is we want to make sure and set a default value, so it has some value that isn't the default of 0, which would be playing. We want it to be unknown state, because when the game state is spawned, or rather instantiate an instance of the game state, we just want it to have something that makes sense, which is nothing makes sense, because we don't know. So we'll say current state equals battery play state unknown. And so set the default state when state is not currently known. Okay? And then we also need to, this is a replicated value, so we need to add our do rep lifetime. So I'm just copy paste that line and put in current state. Okay, now then we have, I think, everything we need for this. We've implemented all three of the functions we created: the get, the set, oh, the rep notify. Let's just add that void ANMP game state, and add the on rep underscore current state. And we don't need to do anything with it right now, so we're just going to leave it blank, but we did need to actually write the function, so we had an implementation to go with that declaration. Okay, now you'll also notice there's a whole bunch of squiggly lines. I found this to be the case when I added the enum, because IntelliSense is just having issues re-scanning and understanding what's going on for some reason. So this should compile okay. And then getting rid of the red squiggly lines, we have to like bail out of Visual Studio and reopen it in order for IntelliSense to catch back up. So that's just a minor annoyance that I found when I was testing this. So we'll just leave that with the red squigglies. We know it compiles. You can see it's successful, and that would be fixed up later. Okay, so now that we have the state, we need to actually handle, our second part of this is to handle transitioning the state. So we need to go from go between the various states of gameplay. And the driver for that is, of course, our game mode. So the game mode is going to drive our game states. So let's go in here to our CPP and see where we're going to do that. Now, we know that, as I said, we need to set an initial state for the game to be, okay, now the game is being played, and the best place to do that is in begin play, when play actually begins. So here, we're going to go in and just say, hey, my game state, and we want you to set current state to battery play state playing. There we go. So we're going to go ahead and add our remark here. This is just transitioning the game to the playing state. Okay, now again, this is our first pass. We're going to go and do other things with this down the road, but for now this will suffice. This will get us where we need to go in this first case, in this first pass. All right, let's go down to where we actually change the states of the game, which we are doing in our drain power, because this is where we give the player power and take away power, or we take away power and all that. So we want to do our state transitions in here as well, and the way we're going to do that is we need to know when you win the game, which is when you have enough power to win, and when you lose the game, which is when your power drops below 0, when you die. So let's handle all of those. So we know you win the game if you have more power than the power to win. So let's go ahead and put that in. If the battery character get current power is greater than, oh, we need access to our game state. Let's just copy this right here. Copy the game state. If it's greater than my game state power to win, then we've won the game. So let's go ahead and say my game state set current state to E battery play state 1. Okay, and then if that's not true, then we're going to check power. So we need to change this from an if to an else if. So if this is true, we do this thing. Otherwise, if we still have power, then drain some from the player. And if that isn't true, then what's true? The player has less than 0 power. Or in other words, the poor player has died. Poor player died. So we need to kill off the player. Now, in a single player version, of course, as soon as one player dies, that means basically all the players have died because there's only one player. And you can end the game. You can go to game over. But is that true for multiplayer? Well, of course not. So we need to handle the case where we have multiple players in the game. So if one player dies, we need to kill off that player, and then we need to stop updating that player's power and stop counting that player toward the game rules. Okay, well, how are we going to do that? Well, the way we're going to do that for this purpose in this series is we're going to actually track the number of players who die, and whenever that number of players who died is equal to or greater than the total number of players in the game, then we know that everybody is dead and the game is over. Okay? So that's how we're going to do it. In order to do that, we need a variable to track. We're going to track the number of dead players. So let's go back into our game mode header and create that. I'm going to go ahead and throw it in the protected section, and it's going to be an int, just int32, and we'll call it the dead player count. So this is track the number of players who have run out of energy and died, and been eliminated from the game. How about that? There we go. Okay, so our dead player count, we need that. So now let's go back into our CPP, and we need to initialize that to a value which is 0. So we need to reset our stats. This is our only stats. So our dead player count equals 0. Now, you might say, well, hey, this is a transient value. We might want to use it on the clients. So why don't we put it in a game state and replicate it? Well, that's a great idea. You could certainly do that. I'm just using it here inside the game mode for this series of videos, so I will leave that as an exercise to the reader. It's not a bad idea. It's just not something that we need to do for now, so I'm going to leave it out. And we also want to do the same thing here. Let's reset our stats. Because remember, you could possibly play around and, let's say, go back to a main menu and play again without actually destroying the game mode instance, which means your dead player count would never go back down. So every time we start a match, we're going to go ahead and reset that dead player count to 0. That way we know everything is good. Okay, so what we need to do then is go back in here. So our player died, therefore we need to add 1 to our dead player count, so plus dead player count. And then we need to check to see, okay, now if this is the last player who died, so let's say, see if this is the last player to die and end the game, if so. Alright, so if that's true, we're going to end the game. So we're going to say if the dead player count is greater than or equal to, how would we know how many players? Well, one way is we could set a value in begin player sum. So let's count up all the players and then track that, and we'll just see if dead player count is greater than total player count. But there's a problem with that, which is, imagine if a player vanished. So a player just disconnected or their computer rebooted or something. Well, that wouldn't really work. So we can't track the initial number of players and expect that to be a value that makes sense. So we actually need to call a function that the engine already provides, which is get num players. And that will actually get the current number of players in the game. So that's what we're going to use. So we're going to check if the dead player count is greater than that, then we need to go ahead and say my game state set current state to e battery play state game over. Okay, so after the last player dies, then we will go ahead and change our state to end of the game. Okay, now is this going to work? One thing that we have to think about though, every time we go to drain power, so every 1/10 of a second or 4 times a second or whatever, we're going to go through, we'll find the player controller, we determine that he has less than 0 power, increment the dead player count. But what would stop us from, again, 1/10 of a second later, going back, again finding the same player with 0 power, and again incrementing the dead player count, and now, pretty soon, after, a 1/10 of a second or two, all of a sudden the game is over even though there's still players around. Well, that's a problem. We need to make sure this only happens one time. How are we going to do that? Well, the way we're going to do that is, this is sort of a preview of some of the stuff we're going to do in the future, because in future videos we're going to actually shut down the player. So their pawn is just going to ragdoll, hit the deck, and the player is no longer going to be able to put input into the game. So we're going to do all that later, but for now we need to make sure that this only happens once. And the way we're going to do that is we are going to disconnect the player controller from the pawn, and that will eliminate this block of code from executing. So let me just go ahead and write that, and then we'll talk about it. So the battery character, we're going to tell the pawn to detach from the controller pending destroy. Whoops. There we go. And I'm going to move the dead player counter down to there. Okay, great. Okay, so now what's happening is we're saying detach the pawn from the controller. So we're splitting them, which means the next time we go through drain power over time into this function, we will get the controller. It will still be a player controller, but when we call get pawn, it's not going to return anything. So this block of code will fail the if check and nothing will happen. That will ensure that we only go into this loop and we only kill off the players one time. Okay? Now again, this is the first pass of this functionality. We're going to move this detach call and do other things when we get around to ragdolling the player after they die. But this will do the job for now. So we're just going to put it here. Okay? So let's go ahead and save. And I think that is all we needed to do for this to all work. So let's flip back over to the editor, do our compile from here, and in the meantime, we want to add the output so that we can see some output on the HUD depending on our game state. We're going to do that in our widget, our power widget that we created earlier. So go ahead and double click on that, and that will open up, and you see we have our power bar down there, and what we're going to do is add a new item, which is our text. We're just going to throw some text in there. Again, we want to anchor this more reasonably to the middle. We're going to go ahead and just throw it in the top. So put it at 0. We'll drop it down 50 units from the top. The size, it could be wider. And let's put it in the middle, so 0.5. And actually, just use size to content. If you click that, then it'll auto size the widget to the text that's in it. So if it says like blank text goes here, then it resizes that for us. So that's good. Now what we actually want it to do is say something in the text based on the gameplay. So we need to bind, just like we did the percentage, we got to bind it. So let's create a binding, and that's going to go right in here. I'm going to drag the nodes apart, and let's go ahead and disconnect with an alt click. And now we need to get the current state of the game, and then we're going to write out some text depending on what that state is. So where do we store the state? In the game state. So let's get our game state, and we need to downcast that to our own game state type, which we will do here. And then as our game state, let me get the current state. All right, now we need to get the current state. Now what we need to do is, depending on the state, we need to take each state and write out some different kind of text, right? Well, how are we going to do that? The way to do that is, and Epic does the same thing in the single player version, so this is really nothing new. We use a select node. So I'm going to hit select, and you'll see it gives me, automatically populates it with the various possibilities from the enum. and it's going to pass in the index. So whatever the current state is, we'll pass that in here, and it will do something depending on the state. What is that something? Well, we're going to make that something be text by dragging the return value and connecting it to that output. And so now it knows that it's supposed to generate text for it. So it says, okay, if ePlaying is the current state, what do you want the text to be? Well, we want the text to be something meaningful, so let's give it some instructions, just like Epic's version of this. Press E, we use E for interact to collect pickups. And then if the game is over, we're going to say, oh, game over. And if a player wins, we're going to say, you win. And if it's unknown, we're just going to leave that blank. So there'll be no text at all. Okay? So now we've got that. Let's wire it up here and wire that straight over there. And again, this looks good, so let's compile. And you'll notice again we have the note here. We have the note because we're not returning a value in the case where the cast failed. So we need to do that. So what we want to do is we're going to make sure that the output has something valid. So let's print some text. And we just want the text to be unknown state. So we're just going to connect to that and short circuit everything and go right out to the output. Now, just like in the percent, I'm going to switch over to the percent function where we did the same thing. For any case where something goes wrong, we simply set the output to something, which is 0, and return a valid value from the function. We're doing the same thing for the text. So even if something goes wrong, we print something to the screen. Okay? Great. Now, you notice here that it says you win. We probably want that to say something meaningful, like player 3 wins or something like that. And we will actually do that in the polish pass. But for now, we're just going to leave it. This is, again, our first pass. Just to make sure all this works, go ahead and compile and save. Notice the note went away. Now we're always returning something. So we're good. We can go ahead and bail out of that. And now, one other thing, we're ready to test this, but one thing I wanted to do before we do that is, so that it doesn't take too long to test the game over case, I want to go to the game mode and increase our power drain delay, or our decay rate. Let's just jack that up to like 0.07. And I'll compile and save that. Okay, and so that's going to make it just drain out power faster. Okay, so let's go ahead and hit play. And here's our two characters on the client side. I'm going to go ahead and grab some power here. And I win. So I collected enough power to win. And you can see both client and server now reflect the value of you win. And of course, power is still draining, batteries are still falling from the sky, and all those things are still happening. And we are going to actually fix that next. In the next video, we're going to start making other changes to the gameplay. But for now, let's go and bail out and run the test again. This time we'll test the game over state. So I'm going to just collect a little bit of power from on the client here to make sure we don't die at the same time. Okay, so now the server is going to die. And we'll see if our instructions continue to render, which means we're still in the playing state, and that is true. And now, as the other player in the game, I died, and lo and behold, it says game over. And you'll notice something weird happened with the client's camera. Don't worry about that. We'll fix that up later. But you can see that the functionality is all working for now. So we're actually transitioning the game state from playing to game over or playing to 1, and that's all working for us. And so we've got that down. Now we need to start making changes to the gameplay so that things happen correctly based on the state. And the first one, which we're going to do in the next video, is to get the spawn volumes to turn on when game starts and to turn off whenever the game is over or the game has been won. So it stops just dropping pickups infinitely. Okay? We will do that in the next video.